Welcome to the solution. The most important skill required to solve this question include owning the dataset, which basically means drawing inferences as we experience the dataset as we read along. Second thing is using options to our advantage. We should also include these options when we are trying to analyze the question. Reason being, think about it. Here there are 3 options, here there are 4 options. So a total of 12 permutations and combinations are possible. What we need to do is select the ones that are an advantage, try to eliminate few early on. The second thing is understanding correlation. What does correlation mean? So just to give you a basic idea, this is positive correlation, this is negative correlation. Nothing more than this is required. If you have this much of basic idea, we are good to go ahead with the solution. The third thing that is important is visualizing our data set. Your power to visualize really comes in handy in solving this question. Let's move ahead and read the question. For a certain electronics retailer, during each of 8 days, so here are the 8 days, both of the graph shows the number of televisions sold and the number of extended warranties sold. Okay, here is television, here is warranties. Understood? Whether for television or for any other products sold at the store. So one very quick inference that we can draw here and that we need to understand is the television sold and warranties sold can be represented with a Venn diagram like this. So what is basically happening, this is television, this is warranty. So there can be warranties of television, there can also be warranties that is not of the television. So say for example, on day 4th, when the number of televisions sold are less and warranties sold are more, so which clearly indicates that not all the warranties sold are for television. So this is a quick inference that we can draw, and it is very important, as in when you read the statements, you should keep on continuously making your inferences so that your mind is very active. The scatter plot also includes a trend line. So this is our trend line. So with the basic knowledge of correlation that we have, we can very clearly see that this is a positive correlation as of right now. So I hope that is not a problem with anyone. Moving ahead. Correlation between the daily numbers of television and warranties sold, and that is a positive correlation that we have established. What the question says now is select from the drop down menu the option that complete the statement so that it is accurate based on the information provided. Okay, what is the question? What is the statement that we need to complete? Among the days represented in the graphs without the data for day, okay, 1, 4 and 6, 1, 4 and 6, the number of daily television and extended warranties sold would no longer be positively correlated, negatively correlated. Okay, so basically we need to work majorly on this graph. So the first step would be to identify point 1, 4 and 6 on this graph, and then we need to work with this option. So as stated in the beginning of the solution, we need to work closely with the options available also. So if you read through the options, no longer be positively correlated, no longer be negatively correlated, but we already have seen that it is positively correlated. So this cannot be the answer, right? Moving on to the next option, still be negatively. Again, it is already positively correlated, so it cannot be still be negatively correlated. So again, this option will be eliminated. So we can easily eliminate 2 options. The fourth option is still be positively though more strongly correlated. Okay, understood. So basically, presently our trend line looks something like this. The 2 option basically says no longer be positively correlated. So our trend line would change to something like this, or still be positively though more strongly correlated, which basically means our trend line will get more steeper. So let us see what is happening. So as a first step, let's identify the points 1, 4 and 6. So the television and warranty values for point 1, point 4 and point 6 are the following. And then I have matched them across which point lies on the scatter plot where. So this is our point 6, this is our point 1 and this is our point 4, right? Now what we need to see is when we remove a certain point of these three, how does it affect our graph? So before visualizing, let me give you a small example to help you make sense of this data, make sense of this graph. So say for example, there are only 2 points. The trend line would be a line that passes through these 2 points. Now say for example, we introduce a third point. Now this was our initial trend line. The new trend line would be something that will go between these 2 points and something like this. So it would shift. So how I want you to imagine this is that every point is pulling the line towards itself, right? So in this case, this point pulls it towards itself. This point is also pulling the line towards itself. Now, the moment this pull is gone, this point is snapped, there is no more force that is acting from this point, the line would go back in the opposite direction. As the pull is gone, the line will move downwards, and thus the line would become something like this. So with this clarity, let us come back to our data set. Building up on our understanding of line of best fit, let us see what happens. So say for example here, let us start with point 4. Now this point 4 is pulling this line towards itself. Now say for example, this point 4 is gone, there is no more point 4. So what would happen? The line will have a tendency to move in the opposite direction. So it will make the line somewhat horizontal. So do we have such option? Yes, we have such an option here. No longer be positively correlated, because this line becomes something like this, which is no longer positively correlated. Now, one more way that you can think of the same thing is once the point 4 is gone, what happens? We only have these many points. Now, if you would see the line of best fit would be something passing through this point, 3 points up, 3 points down. So that is also one way to visualize. So just out of curiosity, let us try the same thing with point 6. What is happening with point 6 here? It is pulling the line. So say for example, it snaps. There is no more a point 6. The line would still be somewhat similar. There will not be much difference. So yeah, same with point 1 here. And thus, therefore, we have our answer. Point 4 here and here no longer be positively correlated. So yeah, concluding, the question really requires you to own the data set and your power to visualize, your understanding of how the line of best fit moves. If you're able to visualize that, you are good to go with this question. Thanks.